In this problem, we want to find all the zeros for the polynomial f of x equals x to the third plus 6x plus 20, given that negative 2 is a zero. Now when we say all zeros, we mean both real and complex. So the way we start with this one, first of all, we should note that n, or the degree, is 3. That means there are 3 zeros, 3 factors that go with this polynomial. And they're giving us one of them, negative 2. So we begin by dividing the polynomial by negative 2 in order to find the remaining polynomial that we could either then factor or solve using other techniques. So we'll start, since this is negative 2 is a 0, we can use synthetic division. So we'll put negative 2 in the box. And then we'll take the lead coefficients of each of the terms in descending order, but notice that we have 1x to the third, but no x squared, so we have to put a 0 as a placeholder, then our 6, and then our 20. So those are the coefficients. Then we skip a line, draw a line, and we start by bringing our 1 down below the line. So now we're ready for our synthetic division. So we're going to take our negative 2 times 1, put it above the line in the next column, that's negative 2, and add down the column. So 0 plus negative 2 is negative 2. Then we do that again, so negative 2 times negative 2 is positive 4. Put that in the next column, add down, 6 and 4 gets us 10. And one more time, negative 2 times 10 is negative 20, and positive 20 and negative 20 add to 0. And that means we don't have a remainder. So the result then, keep in mind this polynomial, the 1, went with x to the third, and when we drop one level, we're dividing out a power of x. So now we're down to x to the second, and again in descending order. So what we really have is this function has been factored. We took out a factor of x minus the 0, negative 2. So x minus negative 2, or we'll come back and clean that up to be an x plus 2. And then the remaining factor is x squared minus 2x plus 10. And if we were to multiply that all out, we'd end up with the original problem, x to the third plus 6x plus 20. But that's not our goal. Our goal is to find all the zeros. So in the remaining factor here, this x squared minus 2x plus 10, there must be 2 more zeros. So we first look at it and see if it's easily factored. So we're looking and thinking, are there 2 numbers that multiply to positive 10 that would add or subtract to negative 2? And just quickly listing out our factors at 10, we have 1 and 10. Those don't add or subtract to negative 2. And we have 2 and 5. And same thing, that we don't get a negative 2. So factoring is not going to get us anywhere. But what we can do is we can take the equation, x squared minus 2x plus 10, set it equal to 0, and apply the quadratic formula to solve. So we're going to need some room. Quadratic formula takes a little bit of room. And just as a reminder, let's write out that quadratic formula. It's x equals the opposite of the b number, plus or minus, square root, big square root, b squared minus 4 times the a times the c numbers, all under that square root, and then a big fraction bar under all of that, divided by 2a. So for our problem, a is the assumed one in front, b is the coefficient of the x, which is negative 2, and c is positive 10. So putting the numbers into the formula, the opposite of the b number is negative 2, the opposite of that will be positive 2, plus or minus square root. The b number squared, negative 2 times negative 2 would give us 4. Now this part is where some students have trouble, so we'll slow down. Minus 4, the a number is 1, the c number is 10. All over 2 times 1, or just 2. Now we'll begin by taking what's underneath the square root, actually the right side of it there, and simplifying that. So we still have the 4. There's just the minus, no other negative, so it stays minus, and then 4 times 1 is 4, times 10 is 40. All over 2. Don't want to forget that. And now we can put together our 4 minus 40, so that's a negative 36. Again, whoops, all over 2. And finally, our square root of negative 36 can be broken down to be square root of 36 times the square root of negative 1. And we know the square root of 36 comes out as a 6, because 6 times 6 is 36, and the square root of negative 1 is defined as the imaginary unit I. So when we reduce that radical, that is, this entire thing reduces to 6i. And now, because it's imaginary, I'm going to separate this and divide each term by the 2. So 2 divided by 2 in front gets us 1, plus or minus 6 divided by 2, 3i. So, keeping in mind we were asked to find all the zeros. So the zeros of this function, we were given the original 0 of negative 2, and we've now found 2 imaginary, or actually complex, zeros. So 1 plus 3i and 1 minus 3i. So the zeros of the function x to the third plus 6x plus 20 are negative 2, 1 plus 3i, and 1 minus 3i.